What kind of study could earn sustained applause from some of the world's leading cancer experts at the annual ASCO meeting? The video you are seeing comes from the 2026 American Society of Clinical Oncology, or ASCO's annual meeting. And at the center of that applause was a drug called Daraxonrasib, a new treatment that nearly doubled overall survival in patients with advanced pancreatic cancer. So hello everyone and welcome back to Physi's Medical Science channel. This is also the very first episode of our new series, New Drug Spotlight. So today we're going to take a closer look at a drug that has generated so much excitement across the oncology community and explore why many experts believe it represents a major breakthrough in pancreatic cancer treatment. Before we talk about the drug, let's first understand the disease it is targeting. If you ask most oncologists which cancer causes the greatest frustration, pancreatic cancer is likely to be near the top of the list. In fact, it has earned a frightening nickname, the king of cancers. People might wonder, aren't lung cancer, liver cancer, or breast cancer much more common? Why is pancreatic cancer given such a dramatic title? Well, there are several reasons. The first is the late diagnosis. The pancreas sits deep inside the abdomen and is surrounded by other organs, including the stomach and the liver. And also, when a tumor is still small, it often causes few or no noticeable symptoms. And as a result, many patients are diagnosed only after the disease has already reached an advanced stage. The second reason is early metastasis, where because pancreatic cancer tends to grow aggressively and it can spread quickly to nearby organs such as the liver. So once the metastasis occurs, treatment becomes significantly more difficult. The third reason is limited treatment options. So for decades, effective therapies for pancreatic cancer have remained relatively scarce compared with many other common cancers. And also, the pancreatic cancer has a particularly poor prognosis, so the overall 5-year survival rate remains below 10%. Because all of these factors, the pancreatic cancer is widely regarded as one of the most dangerous solid tumors. So why pancreatic cancer is so difficult to treat? Even today, with advances in targeted therapy, immunotherapy, pancreatic cancer remains extremely challenging to treat. One major reason lies in a gene called KRAS. Approximately 90% of pancreatic cancers carry a KRAS mutation. KRAS is what scientists call a oncogene. Under normal circumstances, the KRAS gene produces a protein known as the KRAS protein. Inside the cell, this protein functions like a molecular switch. It receives signals from outside the cell and passes those signals on to downstream pathways that control important cellular functions. To make this easier to understand, let's imagine that cell is a company. In this company, KRAS acts like a manager. And under what manager are several important departments. The first is MAPK pathway, which controls the cell proliferation, essentially deciding when cells should grow and divide. The second is P13K pathway, which regulates cell survival and metabolism, determining whether cells continue living or shut down. And the third is RAGF pathway, which controls the cell movement and migration, influencing whether cells stay in a place or spread elsewhere. So in a healthy cell, KRAS receives instructions and coordinates these departments appropriately. It tells cells when to grow, when to stop, when to move, and when to undergo programmed cell death. As a result, the entire company operates in an orderly and controlled manner. But the problem begins when KRAS becomes mutated. You can think of it as a manager whose office lights are permanently switched on. The manager never stops sending orders. The first department affected is a MAPK pathway. It continuously receives signals to expand. It's like the HR department being told to keep hiring more and more employees, so the company grows larger and larger. Next comes the P13K pathway. So normally when a cell becomes severely damaged, it activates a self-destruct mechanism called apoptosis. You can think of this as employees retiring when they get older. But when the P13K pathway is constantly activated, damaged cells refuse to leave. Instead, abnormal cells continue to survive and accumulate. Finally, the Rajef pathway becomes overreactive. This gives cancer cells greater mobility. They begin breaking through normal boundaries, invading surrounding tissues, and eventually spreading to distant organs. In simple terms, a KRAS mutation turns a normally controlled manager into one that never stops issuing growth commands, and as a result, the pathways responsible for proliferation, survival, and migration remain permanently activated, and this can lead to the development and the progression of cancer. Given how important KRAS is in pancreatic cancer, you might be wondering, why don't scientists simply turn it off? In fact, it has been one of the biggest challenges in cancer research for more than 40 years. For a long time, KRAS was considered one of the most famous examples of an undruggable target. But what exactly does that mean? Let's continue using our company analogy. If KRAS is the manager constantly sending out bad instructions, the most obvious solution would be to find that manager and stop them. Unfortunately, KRAS has a unique structure problem. From a protein chemistry perspective, its surface lacks large, stable binding pockets where drugs can easily attach. Imagine a golf ball. Although it has many small dimples on its surface, none of them are deep enough for a drug to lock into securely. For decades, scientists tried to design drugs that could directly bind to KRAS, but it was a bit like walking around with a key and searching for a lock that doesn't really exist. Despite countless attempts, researchers struggled to find a suitable way to target the protein effectively, and that is why KRAS remained one of the most challenging targets in cancer biology for so many years. So if KRAS is so important, but also so difficult to target, how does Daraxonrasib work? Its strategy is completely different from traditional KRAS inhibitors. Instead of trying to find a perfect lock on KRAS itself, Daraxonrasib first binds to another protein called cyclophilin A. You can think of cyclophilin A as a group of bodyguards. So Daraxonrasib recruits those bodyguards and forms a larger protein complex. This complex then surrounds the mutated active KRAS protein. So even though KRAS is still present in the cell, its messages can no longer be passed on effectively. The downstream players responsible for cell proliferation, survival, and migration stop receiving those constant growth commands, and as a result, the cancer cell's ability to divide and spread can be reduced. But the most important question is, does this actually help patients? The answer from the phase 3 clinical trial is very encouraging. So in patients receiving standard chemotherapy, the median overall survival was 6.7 months, but in patients receiving Daraxonrasib, the median overall survival reached 13.2 months. That is almost double. So now, what does median overall survival mean? It doesn't mean that every patient lives exactly 13.2 months. It means that at that time point, half of the patients in the study was still alive, but the other half had passed away. So when we say median overall survival was 13.2 months, it means that half of the patients lived longer than 13.2 months. And compared with 6.7 months for chemotherapy, this is a major improvement. And so for a disease as aggressive as pancreatic cancer, these results are extremely meaningful. And that is why when the data were presented at ASCO, the room broke into long applause. Importantly, Daraxonrasib was not only more effective, it also showed a more favorable safety profile compared with chemotherapy. In the phase 3 trial, the grade 3 or higher treatment-related adverse events occurred in 43.6% of patients receiving Daraxonrasib compared with 57.5% of patients receiving chemotherapy. So in simple terms, Daraxonrasib helped patients live longer, and it was generally better tolerated than standard chemotherapy. For more than 40 years, KRAS was considered one of the hardest targets in cancer research, while Daraxonrasib shows that even targets once labeled as undruggable may eventually become druggable. For patients, this means a new treatment option, but for the field of oncology, it may signal the beginning of a new era in KRAS-targeted therapy. But of course, Daraxonrasib is not a magic cure for pancreatic cancer. The median survival of 13 months still remains as that there is a long way to go before we can truly defeat this disease, but it improves something that targets that once seemed impossible to reach can eventually be reached. And any disease that once seemed untreatable may one day find new hope. So thank you for watching this episode of Physics Medical Science channel. If you enjoy quick updates on new cancer drugs and breakthroughs in oncology, please like, save, and subscribe. I see you next episode.